All right, in this video, we're going to continue our look at a little more complicated trig equations. So here we have sine squared of 10x. Just as a reminder, notationally, sine squared of 10x means the same thing as this. It's sine of 10x squared. Okay, to limit on the writing of all the parentheses, they just convention is to put the 2 by the end there. So let's solve this equation. Again, this can be done without a calculator. I'm going to do what I've done in a previous video, and first note that when you've got a b value in there that's not 1, or an expression in there that's not x, what you should do is replace it with something that is just one variable for the moment. So I'm just going to let w equal 10x so that we're really solving for the moment. Sine squared of w is equal to 1. Okay. Again, we're doing algebra at this point before we do the trigonometry. And we can solve this equation one of two ways. You could square root both sides, or you could subtract 1 and factor. Let's just subtract 1 and factor. So this turns into that, which can factor to sine, it's a difference of squares, so it's sine of w minus 1 times sine of w plus 1 equals 0. And of course, this produces the equation sine of w is equal to 1, and this produces the equation sine of w is equal to negative 1. And now it's time for the trigonometry. Sine is the y-coordinate on the unit circle. So where is the y-coordinate equal to 1? Well, if you draw a horizontal line here at 1, or as best you can, this angle clearly is the solution to the first one. W would have to be 90 degrees. Okay, and then obviously any angle coterminal with that is also a solution. So for this family here, we're going to write W is equal to, in radians, 90 degrees is pi over 2, plus multiples of 2 pi. And just to give myself room, I'm going to move this over a little bit. Okay, and then of course, where is the y-coordinate equal to negative 1 for that second equation? So negative 1 would be down here. And we can think of that as negative 90 degrees. Okay, so then here we're going to write W equals negative pi over 2. And then all coterminal angles mean if you just add multiples of 2 pi, as long as n is an integer, you've got them. Interestingly enough, you could actually write the equations as, you could just say W equals pi over 2 and then add multiples of pi, because don't you see how the answers are spaced 180 degrees apart? Right? You basically have two families of solutions, the purple and the pink, and they're spaced pi radians or 180 degrees apart. So you could actually write this as one succinct equation. Maybe we'll do that instead. So note we have these two families of solutions, but I could also just say or, right? I could just say sine of w is equal to pi over 2 plus pi n. Because by adding pi, I'm basically just getting from a purple solution to the pink solution, or a member of that, the pink solution family. And then if you add pi again, you're back to the purple, and you just keep alternating. And also, it wasn't sine of w, it's w. Okay, but we're not done yet, right? Because w is really a stand-in for 10x. So I'm going to replace the w with 10x. It's equal to pi over 2 plus pi n, and then divide everything by 10 to get our solutions. Okay, so I'm going to say x is equal to pi over 20 plus pi over 10 n, as long as n is an integer. Okay, that gives all the solutions. Obviously, I mean, that's one option. Of course, you could have also done this, right? You could have just done the same thing over here and written your solutions as two families. right? So dividing everything by 10 would produce x is equal to pi over 20 plus 2 pi over 10 is the same as pi over 5, right? And then, of course, in the other, to get the solutions to the other family, same idea. Divide everything by 10, you get x equal to negative pi over 20 plus 2 pi over 10 is the same as pi over 5. Okay, again, with the caveat that n is an integer. Just kind of indicate that there. So your solution, so I've basically done this, given the solution in two different ways. Your solution is either what I'm highlighting in green together, right? It's either this and this, right? Your solution is just to divide it up into the two families, the purple family and the pink family. Or if you want to be more succinct, you could do what I'm doing. I'm going to highlight here in yellow, over here in red, right? That's a little more succinct. They all, either way is fine. Probably the right way is, the one on the right rather, is a little more, like I said, succinct. Let's do another one. It says tangent of pi over 2 times x minus 1 equals root 3. So again, you've got this crazy shift in scaling going on in there, but we can kind of, circumvent the headache of dealing with that by just first replacing what's inside here with some other letter. So let's let w equal pi over 2 times x minus 1. So we can just deal with this equation. Tangent of w is equal to root 3. Okay, so there are a couple ways of thinking of tangent. One good way to think of it is it's the slope of the line through the origin. So we want a slope of a line through the origin that is equal to root 3. Root 3 is like 1.7-ish, so basically a slope a little greater than 1 will be fine. I'm going to draw a visual like this. That'll be good enough. Okay, let's just assume that's a slope of root 3. So the angles that correspond with that point and that point produce all my solutions, at least to the equation tangent of w is equal to root 3. So let's just kind of indicate what we mean here by the slope being root 3. This is the unit circle, so the hypotenuse is a 1. For the slope to be root 3, this would have to be root 3 over 2, and this would have to be 1/2, forcing this angle to be 60 degrees. Okay, so we can say w is equal to 60 degrees in radians is pi over 3. Now here again, let's be more succinct. Let's be succinct like we were above in the here when we noticed the answers were located pi radians apart. Let's just note that obviously to get to this answer here, we just have to add 180 degrees, right? Right, so you add 180 degrees, you'll get to this angle, which corresponds to another answer. Add 180 to that, you get back to an angle coterminal with that. And of course, you could just add and subtract 180, and you just keep getting, the family of solutions from quadrant 1 and the family of solutions from quadrant 3 alternating. So what I'm getting at here is we're just going to add pi n, okay, and that'll produce all the solutions. Now, of course, remember w was just our temporary fill-in for pi over 2 times x minus 1. So we put that back. So I get this, and we solve by multiplying through by 2 over pi. And then adding 1. Of course, let me just indicate over here that n is an integer before I forget. Okay, let's simplify this, and we are done. I'll just finish up by checking the graph as well. Okay, so we simplify by distributing, and 2 over pi times pi over 3 is just 2/3. And 2 over pi times pi is 2. So I just get plus a 2n. Now, of course, the 1 and the 2/3 can add up to be 5/3. So my final answer would be 5/3 plus 2. Oops, this isn't a pi, that's an n. 5/3 plus 2n, where n is an integer. Okay, so I have one solution definitely at 5/3. That's when n is a 0. And then my other solutions are just spaced 2 units apart. If I add or subtract 2 or multiples of 2, rather, I will get more answers. And we can see that graphically here. So I've got the original equation here, the original left side of the equation, and then root 3. There's our first answer, that's 5/3. And the next solution here, of course, is 2 away from that. So you can see once we have one answer and we just add 2 or subtract 2, we are getting all of our answers. All right, so that is just this is another video on solving a little bit more complicated trig equations that might involve some different techniques, mainly this technique of substitution.